So today we're going to be looking at how we can find the zeros of a quadratic function from its graph and what that really means. And then we're also going to be looking at how we can find the axis of symmetry, whether it be from a graph or if we just have an equation for a quadratic function. So first of all, when we're talking about a zero in quadratic, so think of how an x-intercept of a function is when a value of x is when y is equal to 0. So like if I'm talking about a graph here, let me get my pen working. So if I'm talking about a graph here, the spot on the graph where x is going to have the x-intercept is on the x-axis here, and this value right here is going to be where y is equal to 0. So the zero of a function is an x value that makes the function equal to 0. So like if I had any sort of equation, when that x value makes the function equal to 0, that's going to be the same as the x-intercept of a function. So when we're looking at quadratic functions, you could have 1, 2, or no zeros, depending on where that parabola is on the graph. And I'll show you some graphs of which ones would have 1, 2, or no zeros coming up. So what this is going to look like, if I'm looking for the zeros of a quadratic function from its graph, and this is the first one we're looking at, this parabola has 2 zeros. So this point right here is a 0, so that would be at -1, 0. See how that y value is 0. And then this one would have a 0 also at 3, 0. So this one has 2 zeros because that parabola is crossing the x-axis 2 times. Now on this one, this is an example of when there is only 1 0. And this time, this point is going to be at that minimum value of the parabola, the lowest point, the minimum, or what we call this is the vertex of the parabola. So we would say that it has 1 0, and that would be at 1, 2, 3, 4, -4, 0. So this one is 1 0. So that's going to happen when the parabola, just the vertex of it touches the x-axis. And this would be an example of when there are no zeros. So if the parabola is above or below that x-axis, there are going to be no zeros. So what these zeros, one of the reasons why these zeros are important is because it can help us figure out what that axis of symmetry is. So the axis of symmetry is important in a quadratic function because when we have a parabola, the two sides of the parabola are symmetrical. So that means that the left and the right side of it, their points are going to be symmetrical, and the values that they have, there's going to be a pattern with it. So that vertical line that divides a parabola into two symmetrical halves will be that axis of symmetry. Other thing to remember about that axis of symmetry is it passes through the vertex, and we can, if we have that graph, we can sometimes use the zeros to find the axis of symmetry. So like for instance, this one, if I'm thinking about this is my point of -2, 0, and this is my point, my other 0 at 2, 0. What you can think of is, okay, here's my 2 zeros. I know that since it's a symmetrical parabola, I know that that line of symmetry has to be in the middle of these 2 zeros. So if I'm thinking from -2 to 2, that middle spot, that middle line of axis, that axis of symmetry is going to be at where x is equal to 0. So that in this case, it's the origin. Now, one way that you'll often see the axis of symmetry listed is LOS. It's just a short way of writing line of symmetry. So you'll see that sometimes it's kind of a shorthand way of writing that. So when we have a graph, it's easier to see that axis of symmetry. When we are finding the axis of symmetry, if you only have 1 0, so for instance on this top graph right here, this is an example of that axis of symmetry is going to be going straight through that vertex. So that vertex here has the x value here of 3. So that means my axis of symmetry is at 3. So x is equal to 3. Now when you have two zeros, if I have two zeros like this one down here, really what you're doing is you're finding that average of the two zeros, because that's going to give you what the middle of those two zeros would be. So if you have two zeros, you are going to take the two x values, so in this case it's -4 and 0, and you're going to find the middle. Now this one would be pretty easy to be like, oh, it's -2, but if they were harder numbers, you could go and say -4 plus 0 and divide by 2. You're finding that average. So you can see the line of symmetry, or the axis of symmetry on this one, is x is equal to -2. So with the graph here, we can see for A, we're going to have the axis of symmetry going through that vertex right here. So it's going to be at x is equal to 1. And then this parabola on B has two zeros. So I know that it has to be halfway through it. So I'm actually going to look at the points here, which would be 1, 0. And my other point's going to be at 4, 0. Because this one's maybe a little bit harder to see where it crosses. But if I use that average and I go 1 plus 4, and I'm going to divide it by 2, I'm finding that average. 5 divided by 2 would be 2.5. So that 2.5 would be going through this vertex right there. There's my axis of symmetry on that parabola. So now this is going to let us see what the pattern is if, let's say I have a parabola, and even if I have the graph, sometimes it's difficult to see where that axis of symmetry is. So, or sometimes I just have the equation. I don't always want to have to graph it. So this is going to give us a tool or a formula that we can use when we are calculating the axis of symmetry. So I have an example here that's going to help us walk us through why this formula works for calculating the axis of symmetry. So first of all, my standard form here, keep in mind this first number here, the coefficient of x squared, is a, coefficient of the x is b, and the last number, the constant here, is c. So when we're talking about a quadratic formula in standard form, or quadratic equation in standard form, I have my a value, my b value, my c value. So look at these examples here. We're looking for a pattern. So this first function, you can see the graph of it. If I'm looking at the equation, the a value is 1 right there. The b value is -2. And if I do b divided by a, so -2 divided by 1, so I just take the -2 divided by 1, that's how I got that -2. And on the graph, we can see that the axis of symmetry is right here at 1. So we're going to come back to this. I just want you to see how I'm getting these numbers. And so on the second graph, here's what it looks like. My a value is -2. So my b value is -8. I'm going to take b divided by a, so -8 divided by -2, I get 4. My axis of symmetry is right here at -2. And then my last example here that's going to help us along here, we have an a value of -1, a b value of 4, and if I do b divided by a, 4 divided by -1, I get -4. And I can see that my axis of symmetry going through the vertex here would be at 2, so x is equal to 2. So looking at this, we are going to look to see what is the pattern right here. If I'm looking at what I got when I did b divided by a and what I got when I looked at the axis of symmetry from the graph, what's the pattern? So if I go -2 to 1, first thing I notice is I'm always taking half, like just ignore the negatives right now. 2, 1, 4, 2, 4, 2. So I'm always taking half of what the b over a is. And then another thing that I see is like my b over a is negative, then positive. Then this one's positive, then negative. See how it changes the sign? So what that makes me think is that I am really taking -half times b over a. So I'm taking half of b over a, and I'm taking the negative or the opposite of that b over a to figure out my axis of symmetry. So if I write this out, I'm going to actually solve it like an equation. 1 times b, I'm going to get 1b or b, and then 2 times a is 2a, and this was a negative. So see how I get a negative b over 2a? So this right here is actually a super important thing that we use when we're solving quadratic equations. So negative b over 2a is a formula that we can use to help figure out what the axis of symmetry is when we only have the equation, or if when we're looking at a graph, we can't really tell what that axis of symmetry is. And that axis of symmetry, you're going to see as we get into some real world examples, is important because that axis of symmetry is always going to be going through the vertex, which is the highest point or the lowest point on a parabola, which is oftentimes a very important piece of what we're doing. So there we have the formula of negative b over 2a, and we're going to go through an example of what that's going to look like if I'm going to use that formula. So here I have the equation. I don't even need to graph it. I'm going to find the axis of symmetry by doing negative b over 2a. So here's my b, 12, negative b over 2a, so 2 times a, which is 2. So I get negative 12 over 4. So my axis of symmetry would be at x is equal to negative 3. Remember, my axis of symmetry is always going to be x equals negative 3 because that's the line or the x value it goes through. Same one, negative b, same way, negative b over 2a. Here's my b, so 8, negative b over 2 times a, which is 4. So 2 times 4 is 8. So I get negative 1. X is equal to negative 1. So go ahead and try these last two, and then I will go through it, and we'll see how you did. Pause the video, try to figure out the line of symmetry, put it back on, and see how you did. Okay, so if I'm going to go and do negative b over 2a on this one, here's my b, so negative 9 over 2a, so 2 times a is negative b positive, negative b over 2a, that would be a negative 6. So then I'm going to simplify it. This one's a little bit, it's going to be a positive. So if I do 9 over 6, I'm going to divide them both by 3. So I get 3 over 2. So that's going to be x is 3 over 2, or 1.5. And then my next one is a little bit different because I do not have a middle term here. I don't have a trinomial. So that's okay if it's not there. That means that that number for b is actually 0. So I'm going to go 0 divided by 2a, which is a 1 here, so 2. And I can do 0 divided by 2, that is equal to 0. So you will once in a while have the line of symmetry. It's actually going right through the origin or using that y-axis, so x is equal to 0. So that is how you find the axis of symmetry. We'll be using that as we are solving different things with quadratic functions.